Hey guys, at this point we have learned all of the tests. Very exciting. Section 11.7 is a chance to pause and reflect. We had exactly the same thing happen back when we were studying the integration techniques, right? We had a section where we said, okay, let's stop and let's like assimilate all of this information. And let's be presented in the homework where it just says integrate. And we got to figure out right which technique to use. So same idea here. We've gone through a whole bunch of tests. I believe there are 10 in total. And so now we're going to look back and we're say, okay, let's think about how we could identify which test to use. And then, that's kind of nature. Like how do we identify which of these 10 tests is the appropriate one? Now, as a disclaimer, there are series that could be figured out whether they converge or diverge from multiple different tests or perspectives. That's possible. Usually, though, it's not. Usually, there's one test that we want to go with. Or if there's not one test, even some cases, there is one test that's really the better way to go. Where perhaps another one, it's possible. One test, it's like made for that test. And just as a general rule, um, you, you're really looking for which test is appropriate for which series. But yeah, disclaimer: there are cases where you could do it for multiple different ways. Okay, so what we're going to do here, we're going to go through my strategy of how to just like your thought process, right? So there's the actual execution, and we got to be very strong in that area. But the thought process that's going on behind the scenes, that's like unwritten, that is crucial and will, of course, separate folks who will attack your exam and be moving, and other people who might see a problem and just stare at it because they don't even know which test to begin with. Okay, so we're going to go through all the tests, and I'm even going to present them in the order that I will encourage you to follow. So we're going to begin with number one, the divergence test. Now, this is not the first test that we learned. It was actually the second test that we learned, but I would encourage you at least think about the divergence test first. Because if the divergence test works, you're done, right? In just a couple of, just a quick limit, um, it's over, right? So the divergence test, think about your nth term, a sub n, take the limit as n approaches infinity. If that does not equal zero, that's it. This thing diverges and you're done with this question. Of course, in most cases, when you think about that limit, it does equal zero. So I'd encourage you don't even have to write anything, right? Just think about the limit of the nth term. Would it go to zero? Would it not? And if it doesn't, okay, you got it. Often it's the case where people are trying test after test after test, and they never considered the divergence test, um, and so they so they use a lot of time and energy when it could have been done quickly. Okay, so I'd say number one, I recommend think about the divergence test. Number two, maybe you recognize what you're looking at as a geometric series, right? If you see a r to the n or something very close to it, then you might very well use a geometric series test, which is a very fast test itself, right? Just identifying if the absolute value of r is greater than 1 or greater than or equal to 1 or less than 1, right? Now, there is a disclaimer here. There may be some algebra involved to rewrite this to make it look as such. Also, be sure that your series starts with 0. I'm going to say that's really, be sure it starts with 0 if looking to find the sum S, right? S equals A over 1 minus R. If you're looking to find this sum, it's got to start with 0. If you are not looking to find this sum, then it actually does not need to begin at 0. It could start at 1 or 2 or 3 or 10. You would still be able to tell, that R value if it's less than 1 or not. But if you want to find that sum, it's got to start with 0. Okay, so this is kind of like, that's going to be probably pretty clear if it fits this form or not. Another one that should just jump off the page is the P-series test. So I'll list that as number 3. If you see something in the form 1 over n to the p, well, I know I've got a P-series, and that's just as fast as the geoseries, kind of the opposite, in its conclusion. Right here, we want R to be less than 1. Here, we want P to be greater than 1 to converge. So don't mix those up. But in essence, it's a very similar feeling test in that all you got to do is identify whether that's bigger than or less than 1, right? So maybe you can tell right away that that's a P-series. What if you have something that is close to a geoseries or close to a P-series? Then you might want to use a comparison test. Maybe you compare to a geo or a P-series. And so you think, oh, this would be a geometric series if only that one element wasn't there. Or, oh, this would be a P-series if only we weren't adding something in the denominator. I don't know. You say it's so close. Okay, then compare it to that geometric or P-series with a direct comparison test. And of course, I'll encourage you again, use a DCT first. And if the DCT doesn't work out, if the logic is backwards with the greater than or less than nature and the convergence divergence nature, if that doesn't fit, then your fallback is your LCT. And you've already done the hard work. It's just a matter of now executing the limit as n approaches infinity for a sub n over b sub n. Okay, what if it's not one of these at all? What if you immediately recognize your series as an alternating series test? Actually, let me cover this up just for the moment. Well, that would be pretty clear, right? If you have -1 to the n or -1 to the n plus 1, right, then that's an alternating series. Some of these, I'm writing it like a flowchart. It might be obvious it's not a geo or a p. You might immediately see it's an alternating, and you would go straight to that, right? You wouldn't even take any time to think, should I use a comparison or anything, right? So if you identify this as an alternating series test, remember the two conditions. That the limit as n approaches infinity for a sub n must equal 0, and that the values must be decreasing. A sub n is greater than or equal to a sub n minus 1, right? Which you would have to show. If both of those are satisfied, then you know it converges. One thing we got to say about alternating series test, you can only show that a series converges. Alternating series test can only result in converging. You think, well, is it possible to use alternating series to show something diverges? Technically, no. You cannot use alternating series test to show that something diverges. However, we have a fallback. If number 1 here does not work out, if that does not equal 0, then boom, that's the divergence test, right? If number 1 fails, then you can immediately say, perfect, it diverges, but how does it diverge? By the divergence test, it diverges. So we've kind of got that fallback built into alternating series test, but we cite the divergence test when we do that. Okay, maybe it's not alternating. There were a couple more tests here on our list. Next up is the ratio test. How could you identify from looking at your series that you would need to use a ratio test? Okay, there are a couple of just key elements that you're looking for. the series might involve factorials. If your series has factorials, very good chance that you're going to use the ratio test, or the ratio test will work well for that series. Why? Because a ratio test takes a ratio, and factorials cancel out very, very nicely, as we saw in the previous section, right? N plus 1 factorial over n factorial cancels out so well, it's just perfect for the ratio test. Also, constants raised to the nth power cancel out very well when we perform a ratio, as we saw in those examples. So if you see factorials, if you see constants to the nth power, very good chance you're going to use a ratio. Speaking of the nth power, there's also the root test. So we'll put this at number 7. Okay, the big difference in a root test, it's everything is to the nth power. All of the terms are to the nth power. It's not just some of the elements are to the nth power. Everything's to the nth power. If all of the terms are to the nth power, hey, wouldn't it be great if there was a test that said take the nth root to cancel out all those nth powers? Yeah, and there is. It's the root test. So good chance you can use the root test on that. Okay, moving along. Coming back. Now we're going to hit some of the series that we actually studied earlier in the chapter, but I list them later in my strategy here. Number 8, the telescoping series. So if you're going through your list and you're like, I don't see any factorials, I don't see anything to the nth power, I see this other thing. Maybe it's a telescoping series. So a telescoping series will have a form where it's one fraction minus another fraction, right? That's how they generally look. It might not be look that way at first. This may require partial fraction decomposition in order for it to appear like one fraction minus another fraction, and then to go through the steps of the telescoping series. Okay, what if it's not a telescoping series? And this one I'll put at the very end. Number 9 is the integral test. Personally, I find the integral test to be so much work. I really, really, really want it to be a different test. If it's the integral test, I'm like, oh no, right? Because you got to make sure you satisfy those 3 conditions. Is it positive, continuous, and decreasing, right? And then if it satisfies those, then you can begin the test itself. Here's what you might ask if you think it might be an integral test. Can the function version of your nth term be integrated, right? If you were to set up an f of x, could that be integrated? Usually the answer is going to be, it's not necessarily an easy integral. Maybe you need by parts, or who knows. But you should be able to see, yeah, you know what? I could integrate that function. If that's the case, then the integral test is probably a good bet. But I would recommend think about every other test first, just because this is so much work and you have these conditions you have to meet. Okay, so my list only includes 9 when there's actually 10. Why is that? Well, go back here. I really think of these as like one step in my strategy. DCT and LCT I sort of consider together. So technically there are 10 tests, but I lump those as one. So here's what you're going to do. So obviously there's homework from 11.7, so look at that. Also, just underneath this lecture video, I'm going to post a series testing strategy handout. So I'm going to give you 9. I want to say there are 9 questions. There might be like an additional question in there as well. But there are going to be 9 series, and all you're asked to do is go through and identify which test applies to which, and you'll only use each test once. So take a look at that handout. I also am going to post the answer key don't look at the answer key until you try the handout, right? Of course, okay. Um, so take a look, go through that, use every test once. Don't actually perform, don't actually do the tests. You don't have to go through all the steps to figure out if it converges or diverges, but just look through each of those and try and identify which test would be appropriate for each series. On your exam, you are going to see a question just like that. Just simply, which test would apply here? And there'll be one answer, right, how that goes. So what's really helpful here, and what's really the point of kind of sitting and reflecting, this is where true study and deep understanding occurs. Okay, so I just want to end this video with a few words here on problem solving. So this is just helpful. This goes way beyond math and definitely way beyond determining whether series converge or diverge. So when it comes to problem solving, I like to think of it as a tree. So this is my best attempt at, there's a person, right? So this is a massive tree. Think of, here's a piece of fruit sitting up on this branch. Think of the fruit as the goal, right? So I want to reach that. I want to be able to climb this tree and get to that fruit. So the fruit might be getting the right answer, right? The fruit might be getting that job. The fruit might be getting your degree. The fruit might be getting the score you're after on the next test. I don't know. So we focus a lot on procedure. How do I go from the ground up this tree to get to that fruit? Think of the climbing as the procedures, right? So we do all these examples of each of these tests and what they look like, right? And how we simplify them, or just how we express them on the page. All of the steps involved in each of these tests. But here's the thing. Climbing is essential, but it's not all there is to getting to that goal, right? We can teach you procedure, but that doesn't mean the deep level understanding has really stuck. And so, that's going to be why you might look at a homework problem, and if you're not told exactly which test to use, you just stare at it because it's something that's going beyond procedure now. Now you got to figure out which test to use in the first place. Okay. Or if you're going on a big job interview, right, you can study like job interview skills. Do it. That's huge. You need that. You need job interview skills to reach that fruit of getting that job. But there's something else going on under the surface that sometimes goes unspoken, and is a lot more difficult to attain. And that's the roots of the tree, which are the critical thinking. So imagine if this tree did not have any roots, and you know this procedure, and you go to climb that tree. Guess what? This is a big tree, so maybe this is not the best example, but as soon as somebody starts to climb that tree, if there's no roots, what's going to happen? The whole tree falls down, because you start to climb, you put some weight out on that branch, and it's just going to go over, and it's a disaster. Okay, so the tree has roots. The roots are the critical thinking. What's going on beneath the surface that is happening internally, right? Procedure is like external. I know how to go through these steps. Critical thinking happens internally. You don't write your critical thinking usually, right? So the critical thinking is identifying, in this case, in our context here, being able to identify which test makes sense and applies to which problem. Critical thinking is also, hey, maybe you take your best shot at a test, and it doesn't really work out the way you think, and you got to go back and you're like, okay, that didn't work. Well, is there another test here that might be a better fit, that it wasn't so obvious, right? So you got to go deeper with that. So these, what you see here with me, this is a strategy. These are guidelines. That doesn't mean that everything here holds true in 100% of the cases. But take these as guidelines and let that direct you. Okay, that's all I wanted to say about 11.7. Go check out that handout, and good luck with all that.